the quadratic spline interpolation method. Quadratic spline interpolation implies on functions which are more quadratic and which have a quadratic slope, normally which are to the x to the power square. Considering an example in which the x values and y values are given, and these values are given as a table below. The normal general equation of quadratic spline is y is equal to ax square plus bx plus c. The only factor that differentiates each spline from one another are these constants a, b, and c. If we change the constants, then every spline is different from the other. If you observe carefully, then 2 points lie on one spline. Then one equation of a spline should satisfy two points. Then having the 2 points which are 2 and 4 on the line 1, with this is L1, this is L2, this is L3, this is L4. 2 points on the equation of L1, which has the constants A1, B1, and C1. Plugging in the x values and corresponding y values, then 3, the corresponding y value, is equal to 2 squared 4 A1 plus 2 B1 plus C1. Similarly, the other extreme value of x on one line is 4. Then plugging in the x value of 4 and corresponding y value of x, which is 5. And similarly for the other line, plugging in the other two x values, which are 0.4 and 0.6, and their corresponding y values in the equation of line 2, then the equation becomes 5 is equal to 16a2 plus 4b2 plus c2. Then the plugging in this other value of x and y into the equation of line 2, then the equation becomes 7 is equal to 36a2 plus 6b2 plus c2. Then moving on towards the third equation of the line, which is L3, and plugging in the other two extreme values on the line and the L3, then the equation becomes 7 is equal to 36a3 plus 6b3 plus c3. Similarly, we do the same for L4. The other two extreme values of L4 are 10 and 11. If we observe carefully, then each equation has 3 unknowns. Each line has 3 unknowns, and these 3 unknowns are specific to one equation of line. And total we have 4 lines. So the total number of unknowns are 12. To solve 12 unknowns, we need 12 equations. And if you observe here, then we have got 8 equations, which means that we can only solve 8 unknowns. For the other unknowns, we use the slope continuity formula, which states that the slope on the extreme of L2 is equal to the slope on in the beginning of L2. The slope on the extreme of L1 is equal to the slope on the beginning of L2, which means that dL1 upon dx is equal to dL2 upon dx, which means which is normally referred as the continuity equation. Then derivating the dL1 upon dx, which gives us 2a1x plus b1, and on the other side derivating L2, which gives us 2a2x plus b2, and the differential is equal to 0. Then putting all the unknowns on one side, and this slope is equal at 0.4. 0.4 is the point which is common between L1 and L2 both. Similarly, we can have these type of equations in 3 points, because 3 are the interior points within the function of the points we know. Doing the same for L2 and L3 and L3 and L4 at their common points, at their respective common points. So we again get we now get three more equations, which in addition to our previous eight equations has become 11 equations. Now we are still missing one equation, which now we can assume that the function before these functions of before these given functions was linear, which means that a1 is equal to 0. So now we have all 12 equations, and we can plug in it in matrix form. If we plug in it in matrix form, then we get a matrix of 12 by 12, and we have 12 unknown. Then we can easily solve it for these 12 unknowns, which are a1, b1, c1, a2, b2, c2, a3, b3, c3. Plugging in the values of a1 for equation 1, it was 4 and 16, and then we got values of a1 during the slope continuity equation, and at the last we assumed that a1 is equal to 0. Similarly, we got the values of b1, c1, a2, b2, c2, a3, b3, c3, a4, b4, c4, and we plugged them in the matrix, and now we can solve it for a1, b1, c1, a2, b2. Now the question arises, how does it interpolates? Having our equations, having our values of a1, b1 and c1, we can now find any point in between 2 and 11. If it's in between 2 and 4, then we use this equation involving the a1, b1, c1 constants, and we plug in the x value. For example, we have to find the y value at 2.5. Then we plug in the x value at 2.5 and the a1, b1, c1, the constants which were taken out. Then we get our respective y value, which is the interpolation, and it is done in quadratic manner. Thank you.